Hi, it's Farouk, and in this presentation, I will explain the visitor design pattern, its applications, and implementation. To understand where this design pattern comes from, let's take a look at the shape interface and its implementations. We have two derived classes that implement the shape interface, circle and square. The shape interface provides a draw function template that all child objects must implement. This is a simple interface. Let's see what happens if you want to add a new class. Let's call it triangle. We create a triangle class, override the draw function of the interface, and we're done. This will be the same process if you want to add more derived classes of the shape interface, like a rectangle and diamond down the line. But now let's think about what would happen if you want to add translate function to the interface. That will allow us to shift the shape's center point after its creation. Take a few seconds and pause the video to think about the steps involved in adding a translate method to the interface. Additionally, which modification would be more difficult to implement, adding a new method or adding a new derived class, like a rectangle class? So to add a new method in this example, first, we'll need to create a translate method in the interface, and in every derived class from this interface, we will need to implement a translate function. At this scale, it looks like a minor inconvenience to add a translate method to circle and square classes. However, with a big code base, it will involve other people who use this interface to modify their code. Otherwise, their code will stop compiling due to errors. And adding new methods gets more tedious and error-prone as a project gets bigger. When it comes to adding new features, adding a new method to the interface is a more challenging task than adding a new type of an object, like the triangle class. Using inheritance to create new derived classes is one of the strengths of object-oriented programming, so adding a new shape class is straightforward because of it. So suppose you were given the task of drawing different game characters on the screen without knowing in advance what characters would be present on the screen. You could communicate to your coworker that you will follow steps similar to the ones in the previous slide. However, the number of steps will make for a confusing conversation. Alternatively, you could inform your coworker that you intend to utilize the strategy or visitor design pattern. By doing so, you will express the nature of the problem you're dealing with, as well as the general framework of the solution you plan to implement, without delving into the specifics of the code. Design patterns offer general guidelines on how to solve commonly occurring problems in software design, while also conveying intent when communicating. However, they differ from algorithms, in that algorithms provide a step-by-step guide on how the code should be written to achieve a desired solution. Design patterns, on the other hand, are more abstract and provide a high-level structure. It's important to note that two different implementations of the same design pattern may not necessarily be identical. Now, let's go over the implementation of a visitor pattern for shapes. We first create a shape visitor interface with visit functions for each shape implementation. These functions will later be used to implement desired methods. Then we implement different behaviors by creating concrete implementations of shape visitor, the draw and translate classes. If we want to add another method in the future, we can create a new class that implements shape visitor. Finally, we will create an accept method in the shapes interface and define it in every child class. This approach allows us to add new functionality without modifying existing code, making our design more flexible and extensible. In this slide, you can see a couple of nuances of the implementation. When we call the accept function in this implementation, we pass a new instance of the class to the visit function, because draw and translate methods are implemented as classes. As a result, we're not limited just to using single visit function to implement all behaviors. We can have completely different, complex behaviors implemented as separate classes within the visitor design pattern. This gives additional flexibility for selecting the behavior at runtime, on top of encapsulating different behaviors and separating the variation point. In the accept function of the shape interface, the code v.visitVis is used to call the appropriate visit function based on the type of the derived shape class that is calling it. This is achieved by passing this as an argument, and the appropriate visitor method is selected by passing it as an argument to the function. This is how the code structure will look like when using the visitor design pattern. The visitor design pattern consists of a visitor interface. In our example, this would be the shape visitor interface. Concrete visitors, the draw and translate classes, an element interface, shape class, and its concrete elements, circle, square, and triangle. The visitor design pattern intends to add functionality to a group of similar objects and the ability to select behaviors at runtime. This is accomplished with a function selection that happens at runtime. It consists of a visitor interface with all visitor methods defined in it, concrete visitor implementations, and the element class interface, on which we're applying the design. At the core of the visitor design pattern is a double dispatch technique. The first dispatch happens when we call the accept method, which selects the appropriate visit function based on the type of the shape, and the second dispatch is the visit function itself. It selects the method to call based on the type of its input. The main advantage of the visitor pattern is that it allows for localized changes. By abstracting the draw and translate functionality into the visitor interface, any changes made to these methods in the future won't require modifications to the shape interface implementations. Additionally, each method is its own class responsible for a single task, further encapsulating and making the implementation clean and easy to maintain. This implementation also complies with a single responsibility and open-close principles, meaning that it can be easily extended with new methods without requiring modifications to the shape interface. Let's discuss the downsides of using the visitor pattern. The primary disadvantage is the circular dependency it introduces, which can make it difficult to understand and maintain code. For example, classes like Square now depend on visitor implementations, while visitor implementations depend on shape implementations. This interdependency can lead to confusion and makes maintaining code more challenging. Adding new types becomes more difficult as well, because now if you want to add a new type of a shape, we need to be aware of the visitor interface and modify it to add new type. Using visitor design pattern will still require other people who depend on our shapes interface to adjust their derived classes by adding accept functions. Overall, visitor design pattern is better suited to implementing complex behaviors on a closed set of types. This way, the additional complexity that comes with this design pattern does not outweigh its benefits in simplifying the code and making it more maintainable.